All right, let's dive right into this explainer. If you're gearing up for a PHP technical interview, or honestly, just want to bulletproof your backend knowledge, you're in the exact right place. PHP is literally powering millions of sites out there, right? And interviewers, they don't just want to know if you can write the code. They want to see if you actually know what's happening under the hood. So, we've pulled together the absolute most critical interview questions, and we're going to break the whole shebang down together.
Here's the game plan for today. First, core concepts and syntax. Then, we'll navigate web mechanisms. Third, object-oriented PHP principles. And finally, key PHP security practices. Let's get to it.
Part 1. Core concepts and syntax. Time to ground that PHP knowledge.
Okay, so interviewers love hitting you with basic definitions first, just to test your practical coding chops. Here's a classic screener question they'll throw at you right out of the gate. Is PHP a case-sensitive language? Now, it sounds like a simple yes or no, right? But honestly, getting this wrong is an immediate red flag. Because, well, the answer is kind of a hybrid. The absolute crucial point you need to make is that variables are strictly case-sensitive, meaning a variable named $ all caps NAME is a totally different beast than $lowercase NAME. But, and here's the kicker, your function names, class names, and constants, not case-sensitive at all. It's just one of those specific, quirky PHP things that you absolutely need to articulate clearly. It proves you've spent real time actually writing and debugging the language.
Now, check out this strict equality gotcha. An interviewer might lay this out. If x equals the integer 10 and y equals the string 10, what does x triple equals y return? The answer is false. No way around it. And why? Because that triple equals operator, strict equality, checks for both value and type, without doing any sneaky behind-the-scenes type conversion. A double equals would say true by converting the type, but strict equality catches the difference between the integer and the string. It's a perfect way to show you really get how PHP handles types.
Oh, and they might also ask about the spaceship operator. This was introduced to make comparisons way cleaner, and it's a brilliant little three-way comparison tool you'd mostly use for sorting. It's super simple. If both values are equal, it returns 0. If the left side is greater, it returns 1. And if the left side is less, it spits out a -1. It's an elegant piece of syntax, and mentioning it, that shows you're totally up to speed with modern PHP.
All right, moving on to part 2, navigating web mechanisms and connecting to the browser.
This section is all about how your code actually talks to the server and the browser. You are almost guaranteed to be asked to compare file inclusion functions. Specifically, what is the difference between include and require? Both of them pull one PHP file into another, sure, but how they handle failure, completely different.
This is such a great way to show how you handle essential versus optional files in your app. Look, if a file called by include goes missing, PHP just kind of shrugs, throws a warning, and the script keeps right on running. But if a file called by require is missing, boom, fatal error. The script completely snaps in its tracks. So you're going to use require for the non-negotiable stuff like database connections and include for the nice-to-haves like a footer template.
Let's pivot to state management for a second. Tracking lifecycles is huge for backend devs. An interviewer is definitely going to want you to explain the difference between session_unset and session_destroy.
Think of this as your mental cheat sheet. Unset just clears the variables and the data for an active session, but the session itself, the session ID, the file on the server, those stay perfectly valid. It's great if you just need to clear data but keep the user connected. Destroy, on the other hand, completely nukes the session. The data is wiped from the server, the ID becomes totally invalid, the whole 9 yards. You use destroy when a user is actually fully logging out.
Okay, quick piece of trivia. Keep this number locked in your head, 128. As in 128 megabytes. That is the default maximum upload file size set in a standard PHP configuration file. Knowing this little nugget often comes in handy when interviewers start poking around how you handle file uploads or server configs. It tells them you look past just the raw code and actually understand the server environment it lives in.
Let's jump into part 3, object-oriented PHP principles. Time to talk about scaling your application. If you want to prove you can write maintainable code and actually scale an app, you've got to know about treats. Here's the deal. PHP does not support multiple inheritance. A class can only have one single parent. So, when they ask how you get around that, you confidently drop traits as the solution. Traits are an awesome mechanism that lets you reuse methods across totally different, unrelated classes without duplicating code or creating some massive tangled inheritance tree. It's a real game changer.
You also absolutely need to understand dependency injection. This is a design pattern used to implement inversion of control. What does that mean? Well, instead of a class creating its own database connection or logging tool internally, you pass or inject that dependency right into the object. Doing this makes your code infinitely more modular, way easier to test, and just much more flexible overall.
And when they inevitably ask how you write maintainable, scalable, object-oriented code, just immediately rattle off the 5 solid principles. Single responsibility, meaning a class does exactly one job. Open/closed, open for extension, closed for modification. Liskov substitution, meaning subclasses can swap in for their superclasses without breaking the whole system. Interface segregation, keep your interfaces small and hyper-specific. And dependency inversion, high-level modules depend on abstractions, not the nitty-gritty low-level details. Smoothly listing these out, that shows real architectural maturity.
They might also ask you to compare frameworks, right? Because, let's be real, you're rarely writing raw PHP from scratch these days. A great way to answer is by contrasting Laravel and Symfony. You can talk about Laravel's beginner-friendly vibe, rapid development speed, and blade templating. Then contrast that with Symfony, which is definitely geared more toward complex, large-scale enterprise apps. Symfony relies on highly reusable components and uses Twig templating. It's definitely got a steeper learning curve, but the flexibility is just incredible.
All right, final stretch. Part 4. Key PHP security practices. Let's lock it down. Honestly, this topic right here is what separates the junior devs from the senior engineers. Security is absolutely paramount. So explaining how you stop attackers from injecting malicious scripts into pages viewed by other users, non-negotiable. This, of course, is the infamous vulnerability known as cross-site scripting, or XSS.
Frame your answer systematically. Use these 3 steps to make what sounds like a scary, abstract threat feel totally controlled and actionable. Step 1. Escape all your output using HTML special cares so user input is never treated as executable code. Step 2. Validate and sanitize your input. Stuff like filter_var is your friend here. And step 3. Slap on some content security policy, or CSP headers, to strictly control where resources can even be loaded from in the first place. And when you get into the inevitable password discussion, they might ask you to compare older hashing methods to modern ones. You want to emphatically state that password_hash is the gold standard today. Unlike the older crypt function, which was really just general purpose and forced you to manually salt everything yourself, password_hash is built specifically for passwords. It uses ultra-secure algorithms like bcrypt, and the best part? It automatically generates a unique salt for you.
Oh, and whatever you do, don't forget CSRF, cross-site request forgery. This is the one that tricks a poor user into executing actions they didn't actually want to take. Just mentioning that you prevent this by implementing CSRF tokens and utilizing same-site cookies will immediately show the interviewer that you actually understand how to protect state-changing requests in your app. Look, preparing for all these layers, from the basic Quarky syntax to web mechanisms, diving deep into OOP, and finally architecting truly secure applications, that is exactly what's going to set you apart from the pack. Mastering these key interview questions isn't just about memorizing facts to pass a test. It's about proving, without a doubt, that you have the comprehensive toolkit required to crush it in a serious backend developer role. But here's the thing. Getting the job? That's just the start. Because once you're in the seat, the real challenge begins. Getting the code to work is step 1, but how are you going to scale it? I'll leave you with this to ponder. How will you utilize tools like opcode caching, to store precompiled script bytecode right in memory, along with content delivery networks to optimize your PHP app when literally millions of users hammer your servers? Something to think about. Keep exploring, keep building, and hey, good luck out there on your interview. You're going to do great.